Okay, so I think we're live on the record. Let me check. Yep, okay, perfect. So let's go back to any other questions on the homework. All right, pass those in. I should have yelled at me there. All right. Thank you, sir. You're fine. All right. Do I have all the blue papers? Perfect. Okay. And now do you guys all have your guided notes for today? Okay. So today we're going to talk about law of cosines. And you will be happy to know that there is no ambiguous case for law of cosines. Think about this once. Over here, x is positive and y is positive. Over here, x is negative, but y is still positive. So between 0 and 180 degrees, which is the degrees in a triangle, okay? Between 0 and 180, if you're looking at x, and x is cosine, here we're positive and here we're negative. So if I ask you what's the inverse cosine at positive 0.3 or what's the inverse cosine at negative 0.2, there's only one angle that exists between 0 and 180. Okay, so there is no ambiguous case. Notice for sine, for y, if I ask you what's the inverse sine of 0.4, there are two possible angles that could have a positive sine value of 0.4 between 0 and 180. And that's why we had the ambiguous case. Okay, so law of cosines, there is no ambiguous case, and that is nice. Okay, well, we cannot use the law of sines. I do like law of sines better if I can use it. I think it's easier than law of cosines. But it does not work if I'm given side, angle, side, or side, side, side. So think about this once. If I have a triangle and I am given 3 sides, can you use law of sines? Well, you have to have a pair to use that proportion. Same thing is true if you have side, angle, side. So if I have side, angle, side, you don't have a pair to use for law of sines. So in these cases, we have to use the law of cosines. Now, you guys learned the law of cosines last year, okay? But Mrs. Wolf just gave it to you and said a squared is equal to b squared plus c squared minus 2bc cosine of a. And said use it. And next year you'll learn why it is what it is. And that day is today. So if I look at my big triangle, okay? So here's my big triangle, A, B, C. So there's my big triangle. So opposite of angle A is length A. Opposite of angle C is length C, and opposite of side B is, or angle B is side B. So this whole length is side B. If I call just this portion X, well, think about this once. If I let this be 20 and I let this be 5, what would this length be? How'd you guys get 50? You didn't hesitate. You said it's 15 because you did what? 20 minus 5. Well, if this part's B and this part's X, then this part is B minus X. Do you see how that works? All right, so you see how we've labeled our parts. The other part that we labeled here was the height, which you should recognize that the height is just that vertical distance up and down. Okay? So now I'm going to look at one of our right triangles. And we're going to look at just this blue highlighted triangle, which is kind of hard to see, so I'll do that. Okay, that blue highlighted triangle. I can use the Pythagorean theorem, and I can say a squared plus b squared equals c squared. So remember though, be careful, a in this case is the hypotenuse. So a squared is equal to h squared plus this quantity squared, b minus x. All right? And then the first thing they did is they just took b minus x and they FOILed that out. So they just took b minus x and they did b minus x times b minus x. Got b squared minus bx, which is minus 2bx, plus x squared, brought down the h squared. Okay? And then they looked at this, we'll do yellow triangle over here. You can kind of see that yellow triangle. And in that yellow triangle, we can come off to the side and we can say that c squared is equal to h squared plus x squared. You guys agree with that? Pythagorean theorem of the yellows, hypotenuse is equal to c squared or x squared plus h squared. So they just plugged in wait a minute, hang on, did they do this backwards? They expanded first, and then, and then c squared is equal to x squared plus h squared. So in place of x squared plus h squared, they put in c squared. You with me? Okay, and then they said, okay, well, still looking at that yellow triangle, I can say the cosine of angle A, cosine is the what over what?
Opposite over hypotenuse.
No, adjacent over hypotenuse. Which one's adjacent? What's your hypotenuse? C. Okay, how do you solve that for x? Multiply by c. So c times the cosine of A equals what? X. So for x, they put c times the cosine of A. You see how they just plug that in? And then they just rearranged it. They just pulled this in over here and said, okay, a squared equals b squared plus c squared minus 2bc cosine of A. And that's how you can prove your law of cosine. You don't need to know that. Just for those of you who are like, why does this work? It's all a matter of using cosines with multiple Pythagorean theorems. Okay, so here's our law of cosines. First time I show this to everybody, they're like, "Oh, we have to memorize this?" Yes, it's easy. Watch. Yes, it is. Watch. A squared is equal to b squared plus c squared minus 2bc cosine of the included angle. Let's do it again from a different perspective. Let's do it from the perspective of b. B squared is equal to a squared plus c squared minus 2ac cosine of the included angle. Yes? Yes, you did get this last year. Okay? You did. They're doing it right today. Absolutely today. She just told them I'm not proving it for you. I did the proof. You didn't get the proof. She just said, here's the formula. Okay? C squared. C squared is equal to a squared plus b squared minus 2ac cosine of the included angle. It's really not too bad. Watch. We're going to go to our first problem. And of course, you know I'm going to draw a triangle. You need to draw a triangle. It does not have to be drawn to scale, but it does have to be labeled because side A is opposite of angle A. Side B is opposite of angle B. And then angle C is here. Okay, so draw your triangle. And it says solve my triangle. So I am missing angle A, I am missing angle B, and I am missing side C. So I'm missing these 3 pieces. And now I'm looking at this and I'm like, okay, well, I cannot use law of sines. By the way, if you were absent yesterday, make sure you watch yesterday's video because I did talk about the ambiguous case a lot on yesterday's video. All right, so on this, I cannot use law of sines because I have the sine of 32 is to 32.2 is to C, as the sine of B is to 5, as the sine of A is to 8. I have too many variables. I have nothing I can solve. So I can't use law of sines. So I'm going to use the law of cosines. And here's how I'm going to write this. Notice C is what I don't have. So I'm going to do C squared equals. And then you're going to do 5 squared plus 8 squared. So 5 squared plus 8 squared minus 2 times what? 5 times 8 times the cosine of the included angle. What's the included angle? So is everybody okay with how I set that up? C squared is equal to 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of the included angle. Need your calculators, get those out. Now, if you notice that on the right side, I have no variables. Yes, ma'am.
Does it matter? Like, because in the equation, it's C squared equals C squared plus B squared, but you put 5 first.
Oh, it doesn't matter.
Oh, it doesn't? Okay.
No. Yeah, no, doesn't matter. Good question. Good question. All right, if you look at the right-hand side, do you have any variables? Do you guys have any letters of any kind? No. If you don't have any variables on the right-hand side, your calculator is an amazing thing. And it recognizes your order of operations. So you can just type in 5 squared plus 8 squared minus 2 times 5 times 8 times the cosine of 32.2. It recognizes. It does everything the way it's supposed to. Just type it in as one big line. And when you do, what do you guys get for C squared? 21.3. But be careful, that's C squared. So how would I get C? Take the square root. There is no such thing as plus or minus because we're talking about the length of a side. So second square root. No, I'm not going to second square root. Second what? Answer. And when you do, what do you guys get for side C?
4.62.
So let's go to one decimal place. 4.6. Okay, so we got C. I'm going to put it here, and I'm going to put it here. Is everybody good so far? Now we can use sine, however, we can, and I am going to switch to sine because sine is so much easier for the angles, which you'll see in a minute. Okay, so much easier. However, if I have an obtuse angle, where is it?
At A.
Why?
Because it's the biggest side.
Good. If I have an obtuse angle, it will be opposite the biggest side. What's my biggest side? Well, I have 5, I have 8, I have 4.6. Which one's my biggest side? So if I have an obtuse angle, it will occur where? So do not use the law of sines to find angle A, because the law of sines will always give you the acute angle and not the obtuse one. So do not use the law of sines to find what could be the obtuse angle. We're going to use law of sines to find what, Skylar? Which angle?
B.
B. How would you use the law of sines to find angle B?
I did sine 32.2
Uh-huh.
divided over 4.6.
Uh-huh.
Sine of B over 5.
Perfect. She said the sine of 32.2 is to 4.6 as the sine of B is to 5. Cross multiply. What are you going to multiply, Skylar?
4.6.
4.6 times the sine of B and 5 times the sine of 32.2. Divide by what?
4.6.
And I get the sine of angle B is equal to, all right, so 5 times the sine of 32.2, hit enter. Okay, wake up and start punching numbers in your calculator. Divided by 4.6. So I got 0.579. And now how do you find angle B?
Inverse sine.
Inverse sine. Now, I only have one angle here because I know this one is not going to be obtuse because it's not opposite the biggest side. So I'm not worried about the ambiguous case. And what'd you get for angle B? Okay, so angle B is 35 point what? 35.4 degrees. So now I know angle B is 35.4 degrees. 35.4. How do you find angle A? 180 minus 35.4 minus my given 32.2. And what's left for angle A? Ooh. So if I had used the law of sines, would I have gotten it right?
Heck no. Nope.
Okay, so 112.4. So obviously my triangle is not drawn to scale. There's my finished product. Questions? All right, fun stuff. Okay, try another one. Oh, that was a drag there. Okay, I'm going to draw again, not necessarily to scale. A, B, C. Side A is 8. Side B is 9. Side C is 7. So I am missing all three angles. Angle A, angle B, angle C. Now, there are many different ways this is taught. You are going to have teachers tell you find the smallest angle, then the next smallest angle, and then just use 180 minus your two acutes, and if the last one's obtuse, you'll get it that way. You'll have some teachers tell you that. Or you can use the law of cosines to find the biggest angle because there is no ambiguous case of law of cosines. So get it out of the way. Okay, that's what I like to do, but you can do it either way. If I have an obtuse angle, where does it occur?
Across the 9.
Across from the 9, that'd be angle what?
B.
So all you really have to do, you're going to have teachers, professors in your life that teach this different ways. Find the smallest first, find the biggest first. Doesn't matter. Just don't use law of sines to find what? B. Because if B is obtuse, you're not going to get it. You're not going to get it. Okay? So I'm going to find angle B. So because I'm finding angle B, I'm going to go across and start with my 9. 9 squared equals. Now, see if you guys can do it without flipping. 9 squared is equal to what?
2 times.
Not yet. 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of B. Okay, don't touch your calculator yet. Because guys, now do I have a variable on that right side?
Yes.
You must follow order of operations. You must follow, or you cannot just put all of these numbers in as one side. You're going to get it wrong.
Exponents.
Exponents go first. What is 9 squared?
81.
What's 7 squared?
49.
What's 8 squared?
64.
Can I do that math, the multiplication as well? Yeah, you can. What's 2 times 8 times 7?
112.
112.
Just us. Sure.
Now, this is where you guys mess up. If I had the equation 8 equals 9 plus 4 minus 2x, can I add 9 plus 4 minus 2?
No.
No. So can I add 49 plus 64 minus 112? No. What would you do in this red equation?
Add the 9 and the 4.
Add the 9 and the 4 and get what?
13.
13. So what are you guys going to do here?
Add the 49.
Add the 49 and the 64. What do you get when you add 49 and 64?
113.
113. Now be careful. That's like this step. You do not subtract 13 minus 2x. What would you do next here? Subtract 13. So what are you going to do here?
Subtract 113.
Subtract 113. Think about your order of operations in solving an equation for B. What is 81 minus 113? Negative 32. So I get negative 32 equals negative 112 cosine of B. Okay, it's kind of like having negative 5 equals negative 2x. What do you do now? Divide by what? Negative 112. So now I have the cosine of B equals, so now I'm going to grab my calculator and do negative 32 divided by negative 112. And when I do, I get 0.2857. 0.2857. What are you guys going to do now?
Inverse cosine.
Inverse cosine. 0.2857. Now, I'm going to do second cosine of second what? Answer. And what do you guys get for angle B? Okay, angle B is 73.4 degrees. So angle B is 73.4 degrees. I'm going to put it here, 73.4. Now I don't need to worry about law of sines because I know if I had an obtuse angle, it was at B. Now it's not obtuse, so I'm okay. But if it was obtuse, I would have found it through law of cosines. So now I can switch to law of sines. Doesn't matter now if I find A or B.
No.
Doesn't matter. Okay? Because neither one of those will be obtuse, because if I had obtuse, it was B. So, Gavin, which one do you want to find? A? Okay, so how are you going to find A? You're going to say sine of?
Sine A is 2
As?
B is 2.
Okay, so sine, hang on a second. Grab the wrong one. Sine of A is to 8 as? Well, sine of B, which is 73.4, is to what? 9. Okay, how am I going to solve this? So what do you want to multiply? I put the 8 in the front so I don't accidentally multiply it. Okay, and then here. And then do what? 9. And then you're going to take the what? After we find that number, so let's find that number. 8 sine of 73.4, hit enter, divided by 9. Okay, 0.8518. And then how do you find angle A? Inverse sine.
Inverse sine.
Yeah. have second answer. So second sign, second answer. And what do you get for angle A?
58.4.
Did you get 58.41? Did you guys all get 58.4? Okay. 58.4. So how do I find angle C? 180 minus 58.4 minus 73.4. Oh. And what did you guys get when you did that? Okay. Did you guys get 48.2?
Yep.
All right. What should we make sure all those add up to when we're done?
180.
180. So double checking it does. All right. Are we good on that one? Last one, we have a hiker traveling at an average speed of 2.5 miles per hour. How long will it take him to travel from the cave to the waterfall, given this information? Well, first we have to find out how what? Far it is. Can we use law of signs? No. How will I set up this problem? Okay. X squared equals what? So everybody, x squared equals what?
4 squared.
4 squared plus
3 squared
times the cosine of. All right, do I have all numbers on the right-hand side?
Yeah.
Since it's all numbers, I can just grab my calculator. 4 squared plus 3 squared minus 2 times 4 times 3 times the cosine of 71.7. Now I got 17.46. 17.46, but that's equal to x squared. So how do you find x? Square root. Second answer. And what do you guys get? 4.2. So x is 4.2. Now be careful. That's the distance. What did they ask me for?
Time.
Hey, what's the distance formula that you guys learned a freshman year? Distance equals rate times time. How would you solve for time? Divide by rate. So 4.2 divided by your rate of what? Equals your time. So what is 4.2 divided by 2.5? So to the nearest, didn't it say tenth?
Yeah.
What's the nearest tenth? And what would the units be?
Hours.
All right, homework tonight is another worksheet. Some of my kids are like, I'm loving these worksheets. Evens again. Evens again on a separate sheet of paper. I can't tell you enough.
It's all cold. Dude. Only cold. I don't have any. I'm out of paper. Write me a river. Been out of paper weeks now.
Have a good night. Good luck to everybody competing.